Hello there, this is Ms. Nakayama again. Today's lesson is 10.3 Geometric Sequences and Series. So we have a lot of objectives in this video. We're going to cover finding the common ratio of geometric sequence. We're going to write the terms of a geometric sequence. We're going to use formula to find the general term. We're going to use a formula to find the sum of the first n terms. We're going to find the value of an annuity and use the formula for the sum of an infinite geometric series. So let's get started and define a geometric sequence. So the last one we had was an arithmetic sequence where, if you remember, there was a constant difference. In a geometric sequence, that means that each term after the first one is obtained by multiplying the preceding term by a fixed non-zero constant. And that constant is called the common ratio. So in an arithmetic sequence, we're adding the same thing to get to the next term. Could be a positive or negative number. This time we're multiplying by the same number every time. And that number could be bigger than 1 or less than 1, which would make our sequence get bigger or get smaller. All right, so look at this first example, writing the terms of a geometric sequence. So write the first 6 terms of the geometric sequence with the first term of 12 and a common ratio of 1/2. So a sub 1 is 12. A sub 2, so as I just said, you get each term by multiplying by the common ratio. So a sub 2 is going to be 12 times 1/2, which is 6. A sub 3 is 6 times 1/2. You take the previous term and multiply by 1/2 to get the next term. So that's 3. A sub 4 is 3 times 1/2. A sub 5 is 3/2 times 1/2, which is 3/4. And then a sub 6 is 3/4 times 1/2, which is 3/8. So our 6 terms are 12, 6, 3, 3/2, 3/4, and 3/8. All right, to find the general term of a geometric sequence, okay, we have to define that. The nth term or general term of a geometric sequence, if it has a first term of a sub 1 and a common ratio with r. Our common difference before was d. Common ratio is r. A sub n equals a times a sub 1 times r to the n minus 1. Kind of what we just did. But that's the general form. So you can see that each time you're multiplying by that common ratio. So look at our second example. Use that formula to find the general term, and it says find the 7th term of the geometric sequence whose first term is 5 and whose common ratio is -3. So 7th term means I'm looking for a sub 7. The first term is always a sub 1, and the common ratio is r, and so r is -3. So the formula that we just talked about on the previous screen, a sub n equals a sub 1 times r to the n minus 1. So in this particular example, a sub n is 5 times r to the n minus 1. And it is most important, y'all, if r is ever negative or a fraction, you have to put parentheses around it. And again, this is the formula for the general term. If they ask you for a formula, that's what you give them. This particular example says find the 7th term. So that means I'm looking for a sub 7, and I'm going to go plug in 7 up here for n. And when I do and put that in my calculator, then I'm going to find out that a sub 7th, or the 7th term, is equal to 3,645. All right, next, the sum. So before we had the sum of an arithmetic sequence, and that was n over 2 times the first term plus the last term. This one is different. The sum of a geometric sequence of the first n terms, given a sub 1 is the first term and r is the common ratio, which is never equal to 1, then our formula looks like this. A times the quantity of 1 minus r to the n over 1 minus r. So again, as you work these problems, y'all, it is going to be most helpful for you to write them down. Think about that bonus on the test. Write them down as you do your practice problems. You'll have them before the test. Example 3, finding the sum of the first n terms of a geometric sequence. So I have 2, -6, 18, and -54, ... They want the first 9 terms, so that's S sub 9. So my formula that we just gave on the previous screen, S sub n equals A times A sub 1 times the quantity of R, 1 minus R to the n over 1 minus R. So I'm looking for S sub 9. So that means I'm going to go fill in, what is my first term? My first term, of course, is 2. So I'm going to go fill in for everything, and I have A sub 1 is equal to 2. R, what is R? Okay, and R is what I get when I take any term and put it over the previous term. So R in this case is going to be -6 over 2, which is -3. So that's what I'm plugging in for R. And then N in this example is 9. So when you put that in your calculator, and I encourage you to put it in your calculator right now, pause, put it in your calculator, and see if you get an answer of 9,842. If you don't, you need some help with your calculator, please let me know. It's an important skill. All right. Now, we talked about infinite versus finite in the very first section. There is another formula for the sum of an infinite geometric series. But you can only find the sum of an infinite geometric series if your R is between 1 and -1. It could be written as an absolute value. Okay? And if R is between 1 and -1, which means that the infinite geometric series is getting smaller and smaller. And y'all, technically, the only difference between, we've been saying sequence, the only difference between the sequence and the series is the plus sign in between the terms instead of a comma. So that just means you're adding them all up. Okay? A sub 1 is the first term, R is my common ratio, and it's a simpler formula. It's just S equals A over 1 minus R. But you do need to remember, if R is greater than 1, then you can't add them up. You can't add up numbers that are getting bigger and bigger and bigger. These numbers in this series were getting smaller and smaller. So when they get smaller and smaller, then you can tell that they are, it's possible to add them up and find out what they're getting closer and closer to. All right, example 4, find the sum of an infinite geometric series. So I have 3/8 minus 3/16 plus 3 over 32 minus 3 over 64. So it is an infinite geometric series, but to find out if I can find the sum, I really ought to go find out what R is. And R is taking any term and putting it over the previous one. So R is going to equal -3/16 over 3/8. Keep, change, flip, use your calculator. That becomes -1/2. And that is between 1 and -1. So that means I can add these numbers up, this infinite geometric series, using this formula, A sub 1 over 1 minus R. A sub 1 is 3/8. R is -1/2. Again, put it in your calculator and you'll get an infinite. The sum of the infinite geometric series is equal to 1/4. Okay, last thing we got to talk about is the value of an annuity. Annuity is an investment that you have, a lot of people do, and they use it for retirement, and it pays out money to you over a period of time. So we have this big formula. You don't have to memorize this formula. It will be given to you in the problem. Okay, but you've got to know what all the letters in it mean. So you have a deposit that is used, defined in the formula by the letter P. You make a deposit at the end of each compounding period for an annuity at R% annual interest. So R is your interest rate, compounded n times per year. The value A, and that means what it's worth after T years, is given by this lovely formula. Again, P is your deposit. That's your initial investment. R is your interest rate. Got to write it as a decimal. N is the number of times it happens per year. T is the number of years. So this is what you're going to have. Last example, determining the value of the annuity. At age 30, to save for retirement, you decide to deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much will you have from the IRA when you retire at the age of 65? So my formula that we just had was this big old long thing. So what is P? I've got to go figure out what P is. Well, P is my $100 that I put in at the beginning. R is 9.5%, but as a decimal, that's 0.095. N is compounded monthly, so N is going to be 12. And T, how many years is it from age 30 to age 65? Well, T is going to be 35. So I'm going to go plug those in. P is 100, R is 0.095, N is monthly, so that's 12, and T is 35, over R, which is 0.095, and N, which is 12. Again, put it in your calculator, y'all. Make sure you can do this. How much money would you have when you retired? You would have $333,946.30. And that is all you have, except for this formula, y'all. Write them down every time you do a problem, and you will know them. It'll make your lesson checks easier. Thank you so much for watching, and y'all have a great day.